Okay, so as we continue with graphing linear functions and inequalities 1-5, what we are going to be doing is exactly that, learning to graph or making sure we understand how to graph these linear functions and inequalities of two variables. And then our vocabulary, understanding a linear inequality, our boundary line, the closed half plane is going to be when we use a solid line, a open half plane is our dashed line, and of course what our constraints are based on that information. So the typical way that we learned back in algebra how to graph lines looks something like we would have an equation and then we would plug it into a table, we would put in an x, we would get out a y. But in order to do that, using a graph by using a table, we want to get into solve for y, right? We pretty much want to get it into the slope-intercept form, and that was where m was my slope, b was my y-intercept, and then that way it was very easy for us to graph. So in doing so, over here you can see we said, hey, x plus 3y minus 6 is equal to 0. We did some inverse operations over here to get y equals negative 1/3 x plus 2. So I'm going to put in values of x and get out values of y. So when you plug into this equation, x is negative 6, you plug it in for x and you get y is 4. Negative 3, you plug it in, you get y is 3, and so forth. As we plug it into our equation and get our solutions, we put in an x, we get out a y, and that creates my xy coordinates that I am able to graph over here on the graph. Okay, so that's what I'm able to come up with. And being able to understand how to do that and do it with some kind of fidelity and accuracy. So here in this check, we want to do the exact same thing that we did before. Convert it into, move it into y-intercept. So I have 6x, slope-intercept form, sorry. I want to isolate my y. So I will subtract 6x from both sides. And I have 2y is equal to minus 6x plus 10. I'm going to divide everything by 2 to get y by itself. And y is equal to negative 3x plus 5. So there you go. There's my slope-intercept form, so I can plug in some values. And as I get to y is equal to negative 3 times the number plus 5, and I'm just going to make a couple copies of that. And last but not least, and plugging in negative 1, 0, 1, and 3. So that is going to be 8, right? Negative times a negative. This is going to be 5. This is going to be negative 3 times 1 is going to be 2, because you're going to take negative 3 plus 5. And then this should be, negative 4, I think. So let's see. So negative 4, 2, 5, 8. And, well, let's just see what happens. When I graph these, negative 1, and I'm going to use ordered, let's see here. The best thing to do is I'm going to count by 2s, 2, 4, 6, 8. 2, 4, 6, 8, negative 8. 2, 4, 6, 8, negative 8. 2, 4, 6, 8, positive 8. So now I can go ahead and do my ordered pairs, which this should be negative 1, 8. This should be 0, 5. This should be 1, 2. This should be 3, negative 4. Okay. It doesn't matter. I'll just go ahead and 3, negative 4. 1, 2. 0, 5. negative 1/8. Got a linear equation here. And there you go. That is what I can graph using the table. Okay. So using the intercepts now, this is where the value of standard form comes in to calculate my intercepts. So standard form is going to be ax plus by equals c. So we have our x and y on both sides. The x is a positive whole number. And then, so looking at that, we just take y. When y is 0, we have a x-intercept. When x is 0, we have the y-intercept. So we just take the equation and we plug a 0 in for y, which would be leave 3x equals negative 12, divide both sides by 3, and x is negative 4. So that would be ordered pair of negative 4, 0 is my x-intercept. And then the y-intercept, when we plug 0 in for x right here, you have negative, this becomes 0, this becomes 0. Negative 2 minus equals negative 12, divide both sides by negative 2, and that becomes a 6. So the ordered pair is going to be 0, 6. So that is how to find my intercepts real quickly using standard form. And then over here, when I go to graph it, I know that, let's see here, negative 4, 1, 2, 3, 4, and 0. That is my x-intercept. My y-intercept is 0, 6. And I have graphed that equation. And that's it. That's the value of standard form. It gives you your intercepts real easy, and you can get 2 points to graph. Slope and y-intercept, I put it over here in the margins for us. Just remember that y equals mx plus b is my slope-intercept form. M is the slope, which is the rise over run. It is in your reference sheet, so my slope is equal to y2 minus y1 over x2 minus x1. And then your y-intercept, b, is your y-intercept, which will tell me where it crosses over the y-axis. So here, looking at this graph, I will just say that 3 over 2 is going to be my slope. Negative 4 is going to be my y-intercept. This is 3 over 2, and this is negative 4. So the value for my y-intercept is going to be 0, negative 4. 0, negative 4 is my y-intercept. And then the slope allows us to go ahead and move. So from the y-intercept, we would move up 3 and right 2. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So it looks something like that. Okay, we've been doing that 7th, 8th grade. So that is one of those skills that, that's the very first way that we learn to graph equations and functions, is using slope-intercept form. Let's see, so we're moving up 3, we're moving right 2, plot a point at, we plotted a point at 2, negative 1. From 2, negative 1, again, we moved up 3, right 2, and we plotted a point at 4, 2. And then there you go, that's what we could do. Different from a table. For linear inequalities, okay, so a graph of a linear inequality is a half plane with the boundary that is a straight line. The half plane is shaded to indicate all the points that are contained in the region are solutions to the inequality. So whatever the inequality is, everything over here in the yellow is going to be a solution. And then the boundary line is a line or a curve that separates the coordinate into 2 halves. So you have the solution side, and then the not solution side, And I will tell you that this would technically be a closed function because it's a solid line, but we'll learn more about that when we move to the next page. Okay, so a boundary is a is solid when we are graphing an inequality. If you have a linear inequality, if you have less than or equal to or greater than or equal to, think about it. When we would graph on a number line, we would simply use a solid dot, closed dot. That's when you have a solid line in graphing. So that is let's think of those two things together. When I have a solid dot, I have a straight line, solid line. When you used less than or greater than, you had an open dot, so that would be a dashed line because the things on the dashed line are not included in my solutions. Okay, so with that, let's see, moving forward. Graphing an inequality with an open half plane. It is open because we have, in this case, it looks like we have greater than or less than, so it's going to be a dashed line. So they went ahead and we want to put it into y equals so we can graph it like if it were in slope-intercept form. So they subtracted 12 from both sides. So now we have negative 4y. When you divide by negative 4, you have the golden rule there that you have to reverse your sign. So instead of being greater than, y is now less than, and divide that by negative 4, so we should have negative 1/4 plus 3. So y is less than negative 1/4 plus 3, and because the inequality is this, the boundary is open, and it's going to be dashed. So just keep that in mind when we are graphing our line. So starting off at my y-intercept of 3, I am going to go ahead and I am going to, looking at my slope, slope is negative 1/4, I am going to go down 1 and I am going to go right 4. So down 1, right 4, down 1, right 4. The other option is that I can go up 1 and left 4. So basically I am going to go a positive 1 and then a negative 4. So you do have that option because you want to be able to graph in both directions. Oh, remember it's supposed to be a dash line. Okay, and now you have to test which way are we going to shade. So the easiest thing to test for me is just test your origin, which is 0, 0. So here we have 12, and then minus 4y is greater than x. That's what we started off with. If this was 0, right, y was 0 and x was 0, that would be 12, and this becomes 0, is greater than 0. And is that true statement? Is 12 greater than 0? It is greater than 0, so that means that we are going to shade the 0, right, the origin. So the origin is the side that gets shaded. And there you go. That's one way to do it. Another way to do it is when I'm looking at the name, it says y is less than. So if we think about my y-intercept, I want to shade all the y values that are less than that, which is also shading in the downward side, downward direction. So there you go. That's the easiest thing to do. Graphing this inequality with a closed plane simply because we have an equals to sign. So they did the same thing. They went ahead and manipulated their function and got to the point where they have y is less than or equal to 8 over 3 x minus 3. Okay, so that's it. I know that my boundary line is going to be closed. It's going to be a solid line when I go to graph it. It is y is less than or equal to 8 over 3x. Get that right? Yeah. And then over here graphing it, goodness. Uh, minus 3. Y is equal to 8 over 3x minus 3. Graphing that, starting off here at negative 3, my y-intercept, and I'm going to go up 8, and I am going to go right 3. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. So there you go. I know I'm going to have a solid line because it's closed. And then when they test it, they threw in, again, 0, 0. 0, 0 makes it 9 is less than or equal to 0, and that is not a true statement. So that tells me that we need to shade the not 0, 0. So we would shade over here, basically down. Shading down, okay? And if you think about it, I messed up here. This was less than or equal to sign. So y is less than. So just think about from my y-intercept, I'm still going to shade everything less than, which happens to be to the bottom or what appears to possibly be the right, bottom and right. Okay, so linear inequalities. Let's see here. Malik's algebra teacher determines semester grades by finding the sum of 70% of the student's test grade average and 30% of the student's homework grade average. If Malik wants a semester grade of 90% or better, write and graph an inequality that represents the constraints for Malik's test grade and homework grade. Okay, so Malik wants a grade of 90%. Okay, and it says determines the semester grade by the sum of 70% of the student's test grade and 30% of the student's homework grade. So that means that, in that big piece of pie, I like to think of my grade, right? My grade here, basically, they're saying that this is homework. Homework is 30%, and then 70% of it is going to be the test grade. So that's how that student or that teacher determines grades. This is sort of close to mine. Describe the task in your own words and list any questions that you may have, and how can you find answers to your questions. Okay. Let's see, looking at some more stuff. How will you approach the task? Well, I need to know that 90% is going to be 0.9. That's going to be important for me because that's going to talk about the total grade I want, or the minimum grade I want. What have you learned that you can use to help you complete the task? I know that he can have a grade of 90 or better, so better than, y, it's going to be greater than or equal to. Y is going to be the homework average, x is going to be the test average. So my linear inequalities. And so the looks something like 0.7x, because that would be my test grade, plus 0.3 homework grade is going to be greater than or equal to 0.9, which would be 90%. So we don't want it less than 90, but we can have it greater than 90. So which one of these viable solutions for Malik's test and homework grades? Well, I'm going to tell you, let's use the standard form to come up with my intercepts. So when I go ahead and calculate my y-intercept and my x-intercept, they're off the charts. If my test averages were 0, then I would need greater than 3, which is not really a possibility, right? Because that would be 300%. But that is way off my chart. So it'd be up here somewhere. And then coming down this way. And then if I had my homework grade was a 0, I would need approximately 1.3 or 130%, which is somewhere around here. So that's why we shaded it. It would be all of this region here. Now, on a test, we're limited. We can't get a 300% or 130%, so we have to think what falls in this region right here. So let me erase that a little bit. You know, we know that that's what it's supposed to be. Okay, and then which test grades? Let's see here. So if I wanted to look here at 88% test and homework grade, this is my test grade, 88%, and homework grade of 100%. That is probably going to work. It seems very close here. That would work. A test grade of 90 and a homework grade of 90. So that would be right here. That is probably also going to work. 90 and 80. Now that one doesn't seem like it's going to work. So a homework grade of 80% and a test grade of 90, we are outside of the zone that would make it favorable for us. Let's see what else. 95 and 70% homework. Again, 70% homework and 95 is about right there, so we're outside of the shaded region. And then 95 and 80% homework. 80% homework right along here to a 95. That is probably within our boundary. It seems to be on the line. And then 100% and 70% on homework. Again, 70% on homework all the way over here. That is probably on the line too. So there you go. Those are the answers or the solutions that would work for us there. So, and with that, you know, we just want to be able to look at our constraints. And that was what we were talking about here, is the constraints, that it can't be grades down here. It has to be a grade greater than 90, total average combined. So here our constraint was it had to be less than. So just thinking about how can we graph these things and give the information. So a little bit of practice, be meticulous with your graphing, because if you can't read the graphs, they don't mean anything. So your responsibility when you're doing this kind of work is to be able to show evidence to where if somebody comes behind you and looks at your work, they can tell exactly what you were thinking and your numbers make sense.